Uh-oh. So, I am unmuted, I think. I'm just gonna hope that this is going the way I think it is. I'm gonna check my audio. For whatever reason, it is being funky. All right, so here are the notes for section 7.5. Sorry, this had to get re-recorded because they changed it this semester and all kinds of funky things have happened. So this is a new video just for y'all. So let's start with, so in 7.4, you learn to look at the equation of a parabola and think about where that parabola is in space, right? Like, and know how to graph it from there. So today we're gonna, in this video, we're gonna do a little more of that and then think about the applications. We're gonna look at graphing a little differently. So first, what we're gonna talk about is based on a graph, can you find the vertex, the intercepts, and the axis of symmetry? Well, of course you can. So remember that vertex is the point at which your graph turns. So really, you're just looking for the spot where it goes from increasing to decreasing or from decreasing to increasing from left to right. So in this graph over here that I see the vertex is, oh, I need the pen to work. The vertex is at, let's see, 1, 2, 3, and -2. So that's the vertex. Not so bad. Every parabola has intercepts on some level, like not every parabola has. So let me start that thought over. You can tell how it's going here today. A parabola has either no intercepts, 1 intercept, or 2, okay, because of the way it's shaped. So if it's up in space, it's possible that it doesn't have any. It's also possible that it has 1 because it only crosses the y-axis once, or it has 2 crossing the x-axis in 2 places. Honestly, it could have 3. It could cross the y-axis once and the x-axis twice. So in this case, good Lord, that was a really long roundabout way to get to, there's only 1 here. You see that because of where the parabola is positioned, it's only going to cross the y-axis in 1 spot. And so what I need to list here for my intercepts is that this is a y-intercept, and it's crossing the x-axis at 0 on x and -6 on y. The axis of symmetry is the line on which my parabola would fold, okay? Like a butterfly. Think about paint butterflies with little kids. So the line on which it's going to fold is where x equals +3. That's it. That's all we have to do here. All right, so let's do another one. So in the same way, we're going to find the vertex, the intercepts, and the axis of symmetry. So stop the video for a second and do that. And then let's talk about it. So the vertex is, let's see, at -4, -2. That's the vertex. There's a bunch of intercepts here, right? There's x-intercepts at 0 and -6. Oh, sorry, -6 and 0. Good gravy. -6 and 0. And at -2 and 0. And then there's a y-intercept at 0, +6. And please, when you do this, label stuff because I'm not a mind reader, right? And then the axis of symmetry is the line on which my parabola is going to fold in half. That's going to be right at the vertex point at x equals -4. So far, so good. You probably like this section. So from here, sometimes what we have to be able to do is in 7.4, you saw that if an equation is written just in the right way, you know, in that HK formula setup, it's really easy to see in a graph, see in the equation how the graph will look. But it's not always going to be like that because sometimes your equation is going to be in standard form. And that doesn't work as well. So when we have that happen, we have an alternative. This is the alternative. This is called the vertex formula. What this lets us do is find the vertex of the graph And then once we find the vertex, we can find the intercepts and we can graph. That's all we need to do. We're going to find the same stuff. We just don't have it staring at our face in the equation. Okay, so the vertex formula, the way you do this, there's two choices really. The first way is that the x-coordinate is negative b over 2 times a. That's it. And then the y-coordinate would be 4ac minus b squared over 4a. For me, I find this first way to be a little more complicated because the other option is to find x the same way and then to put the x value into the equation to get the y value. You'll see what that looks like. That's what we're going to do. This I find hard to remember personally. So we're going to use the vertex formula here. First, we're going to lay out, I know that a is 1, I know that b is -2, I know that c is 5. So in order to do this, to find the x-coordinate, I need to do -b over 2a. Well, -b is -2, which is just 2. 2 times a is 1. So that would be 2 over 2, which is the same as 1. So the x-coordinate in my vertex is 1. What I'm going to then do with that is set up my equation as y equals x squared minus 2x plus 5. And I'm going to put 1 in wherever I see x. I'm going to find f of 1, basically h of 1 in this case. So I'm going to do 1 squared minus 2 times 1 plus 5. Let's see, that's going to be 1 minus 2 plus 5. 1 minus 2 is -1. -1 plus 5 is 4. And that is my y-coordinate. And that is it. I have the vertex. Ta-da. That wasn't so bad. Now I need to find the x and y intercepts. So the y-intercept is easy, right? I'm just going to put in, for the y-intercept, I put in 0 for x. Easy enough. So I'm going to do y equals 0 squared minus 2 times 0 plus 5. Well, that's going to get me 5. So the y-intercept is at 0, 5. Happy days. The x-intercept is the part where we have to solve for x. Okay, so this is a quadratic. Okay, I'm going to look at it. So I'm going to put 0 in for y, x-intercept in for y. Okay, so I'm going to get 0 equals x squared minus 2x plus 5. And now we need to pick back into our factoring. So I'm going to look at it. Can I factor it easily? No. Can I complete the square? Not so much. Can I use the square root property? Meh. Well, if that's all not going to work, I need to drop into the quadratic formula. So you know what that is. It's -b plus or minus b squared minus 4ac over 2a. Yes, you do have to memorize that, friends. You have to, not optional. And I'm going to put things into place. So I'm going to do 0. Sorry, I'm going to do, I don't know why I went 0, 2, negative b. So -2 would be 2 plus or minus the square root of -2 squared b squared minus 4 times 1 times 5 all over 2a. Oh, 2 times 1, I wrote a. So 2 plus or minus 4 minus 20 over 2 is going to get me 2 plus or minus square root of -16 over 2. Oh, that's not good. It's not bad, but whatever. Over 2. That's going to be 2, and I'm going to simplify that -16 into 4i plus or minus 4i over 2. I can cancel a 2 out of everybody, here, here, and here. So it's going to give me plus or minus 2i. So here's the problem. Oh, sorry, 1 plus or minus 2i. There are no imaginary things on a graph, right? So if I get to this point for the x-intercepts and I get an imaginary number, there are no x-intercepts. Because x-intercepts have to be real. They can't be imaginary. So that's something to know. So now I know something about my graph. I know the vertex is at, let's see, 1, 4. So 1, 1, 2, 3, 4. I know it crosses the y-axis at 0, 5, which means this is here. It goes like this. And now I can graph my parabola. Ta-da! All right, here's one for you to try. Vertex formula first. Get the x and y intercepts. Draw the graph. Okay? Take a second. Do it yourself before you watch me do it. All right, I'm going to do the vertex first. So let's see. I'm going to do negative b over 2a. That's going to be negative 4 over 2 times 1. That's going to be negative 2. Fine. And then I'm going to put negative 2 into the formula for x. So that's going to be negative 2 squared plus 4 times negative 2 plus 6. That's going to be 4 minus 8 plus 6. Negative 4 plus 6 is positive 2. So my vertex is at negative 2, 2. Simple enough. Intercepts. Well, the y-intercept is easy enough to find because I'm going to put in zeros for x. So 0 squared plus 4 times 0 plus 6 is just going to be 6. So my y-intercept is at 0, 6. Great. Now I'm going to solve for my x-intercepts. I'm going to look at it and I think, let's see, can I factor it easily? 3 and 2, 6 and 1, nope. So I'm going to go good old quadratic formula for the x-intercepts. I'm going to do negative 4 plus or minus the square root of 4 squared minus 2 times, where did I get 2? 4, that's, b squared minus 4ac, 4 times 1 times 6. I'm going to get over 2a, that's 2 times 1, so I'm going to get negative 4 plus or minus square root of 16 minus 24. Already a problem. So I'm going to get negative 4 plus or minus the square root of negative 8 over 2. Right here, I know this is going to be an imaginary number. So that tells me there's no x-intercepts. Again, that's fine. So now I'm going to graph. So I know where the vertex is at negative 2, 2, right there. I know the y-intercept is at 0, 6, which is up here. So I'm going to draw a corresponding point over there. That makes that there. Oops, sorry. And there. And here is my parabola. Life is not so bad. This is how these work. Okay. It could be an Alex that it throws the midpoint in at you. Midpoint formula. You don't need to do that. Just do this like this. It will be easier in the long run. So now we have to use this to do stuff. And here's how it works. So you have some kind of a question like this. The crew from, Extravaganza Entertainment launches fireworks at an angle of 60 degrees from the horizontal. Okay, that's fair. The height of one particular display can be approximated as h of t equals negative 16t squared plus 128 square root of 3t. H of t is measured in feet, so that's height, and t is measured in seconds. So how long will it take for the fireworks to reach their maximum height? Well, let's think about that. The maximum height, think about what happens with the firework. They're going to shoot it off, it's going to go up, and then it's going to come down. The maximum height is the vertex of the parabola. Okay, I want to be right here. So if I think about my lines, so I need to find the vertex. Okay, so if we think about our graph, wherever this vertex is, the amount of time going by is this way. This is the height, right? Okay, so think about which coordinate it's going to be. Okay, so the x coordinate is going to be time. The y coordinate is going to be height. So first I need to find the x coordinate. So negative b over 2a. And there is no c, there's like an imaginary 0 here. So negative b is negative 128 radical 3. You have a calculator, that's just a number, over 2 times negative 16. Okay. So on the top, that equals to, I don't know, something. Do it in your calculator. It comes out to be somewhere in the neighborhood of 6.9. And that will be in seconds. So now that I have 6.9, I'm going to put that back. I'm going to round it to the nearest second. Let's call it 7. I'm going to need my calculator, but it's not anywhere near me. Of course, I'm going to put that back into the equation. So I'm going to call that 7, right? And I'm going to go, okay, negative 16 times 7 squared plus 128 square root of 3 times 7. Okay, so I didn't use 7, I used 6.9. So if I use 6.9, I get the value here as 768. So it should be in that neighborhood. That is your y coordinate. That's the height. So we're going to do that in, let's see, feet, right? All right, fair enough. Oh, sorry. This said, how long will it take? How about reading? How long will it take is the time. It's about 7 seconds. What's the maximum height? Round to the nearest foot. We did that. 768 is what I have. Okay, you see how this works. The next question is very similar. So an object is launched into the air with a velocity of 48 feet per second from the top of a building 288 feet high. The height after a certain number of seconds is given by this formula. Find the maximum time it takes. Find the time it takes the object to reach its maximum height, the same thing, okay? And the maximum height. So this is the x value. This is the y value of the vertex. Fair enough. So do what we just did. So negative b over 2a would be negative 48 divided by 2 times 16. That's going to be 1.5. Well, so it's going to take 1.5 seconds to reach its maximum height. It's going pretty fast. And then I'm going to take that 1.5 and put it in for t. So I'm going to do negative 16 times 1.5 squared plus 48 times 1.5 plus 288. You have a calculator, you should use it. And then I'm going to get, let's see, 324. So that's the height at the time. Feet, right? Yeah, that's it. That's all there is in this section. You can do this. If you have questions, you should reach out, okay? I would love to help. So practice, see where we're at. I'll see you on the next video.